Here's some more problems from section 10.2, and this is number 37. And if you read in the book, it says 37 and 39, the velocity of a particle moving in the plane is given, along with the position of the particle at time t equals 0. Find the position of the particle at time t equals 3. Find the distance traveled from t equals 0 to t equals 3. So first of all, this is our velocity that's given. This is v sub 1 of t or v sub 2 of t, or it could be x prime of t, y prime of t, same thing. And the initial position is 2, 6 when t is 0. That's what we have. So we want to find the displacement first of all, then we want to find the position, because they ask you to find the position of the particle time t equals 3. So first of all, we want to find out what our displacement is from 0 to 3, and then we'll add the initial position, then we'll get the final position. Okay? So remember, the final position is equal to the initial position plus the displacement, and that's what we're going to figure out over here. So remember, we have our formulas of displacement is equal to the integral from a to b, in this case 0 to 3, of my v sub 1 of t dt. And then that's my horizontal displacement. My vertical displacement is the integral from 1 cosine pi t from 0 to 3, and this would be the y prime of t, or y prime is the function of t, which is the v sub 2, the x, y. They kind of notate it like this in the book. So just to follow that notation, so we just take these two integrals. If I integrate this is going to just be 3t cubed over 3, 2t squared over 2. And I'm going to integrate that from 0 to 3, so that's going to be just t cubed, which is 27, minus t squared, which is 9, which is 18. Then over here, this is easy enough to do. Now, we can break it up into two integrals, which I did over here, 1 dt plus the integral of the cosine of pi t dt. And what we have is we've got a U-substitution here, because we've got a chain rule involvement here, or a composite function. So this is going to be cosine of pi t, so u would be pi t, so du would be pi dt. I've got the dt, I don't have the pi, so I've got to put a pi over here. So I've got to divide by pi, make that just 1. And now we have it in the form of the cosine of u du, and the antiderivative of that would be just the sine of u. Put parentheses around this. Okay. But I've got the 1 over pi. That was my adjustment to accommodate for the du. And then over here, this is just going to be the antiderivative of 1 with respect to t is just t. We evaluate that from 0 to 3. I put 3 in there, I get 3. I put 0 in there, I get 0, so I just have this. And then I've got to evaluate this from 0 to 3. I can take the 1 over pi out, and I've got the sine of 3 pi. And actually, the sine of 3 pi is 0. Okay. Comes back up, multiples of the sine of pi are 0. And then if I put 0 in here, that's just going to be sine of 0, which is also 0. So those both go to 0, so my second term is just 0, so I just have 3. So there's my displacement. Now again, remember the final position is and we've done these before in just velocity problems, the final position is the initial position plus a displacement. My initial position was a 2, 6. This was my displacement, so we just add the components. 2 plus 18 displacement is 20, 6 plus 3 displacement is 9, so there's your final position. Okay? So I hope that makes sense. It would have been faster if we just used our calculator on these, but we could do them by hand, so you need to be aware of how to do that. And then letter B, we want to find the distance traveled, so we've got a nice formula for that. And that, again, is just like our basic formulas we learned in AB. The distance traveled is just the integral from A to B. It's just travel from A to B. It's the integral of the absolute value of the velocity. And the absolute value of velocity is the magnitude of the vector. The magnitude of the velocity vector, which is just v sub 1 squared plus v sub 2 squared, the square root of that. And again, this could be like x prime of t, y prime of t squared, x prime of t squared, or dx dt squared, dy dt squared. Lots of ways to notate that. This is just what our book is using, so I just use that notation. And that's the distance traveled. So my x component of my velocity vector was this, so we squared. And the y component of my velocity vector was this. You can see that back from up here. X component, y component of the velocity vectors, and that's what we're trying to find is the magnitude. That's going to give us the distance traveled. So we put this in our calculator. And I didn't really want to square this out and combine all these terms and then take the square root of that. It'd be probably pretty much difficult to do. So we just evaluated that. So we just used our math 9. So we took the square root. And then I could have y-var'd these and made them a little bit easier. Put this in y1 and this in y2. And then this could have been just the square root of y1 squared plus y2 squared. Might have made it a little easier. Might not even need the parentheses, but I just put it in this way also. You could do it like this. But like I said, I would probably put this in y1, this in y2, and then var y vars. Make it a little bit easier here. So I'd say y1 equals 3t squared minus 2t. And y2, I would probably say that's equal to just the cosine x. And then when I did this, I would just f(n)i(t). And I would just have y1 squared, the square root, pardon me, of y1 squared plus y2 squared, comma x, comma 0, comma 3. And you could do it like that. That might be a little bit easier. Or you could do it like this. Either way, you're going to get about 19.343, and that's your distance traveled. I think in class we might have done it like this. I'm not too sure which way. But either way it worked. But this makes it a lot simpler. Okay. So that's the distance traveled, and those are just right off of our notes, so those are pretty straightforward.